Okay, so I'm going to start with a fresh set of notes for example 3. For example 3, we have an observer of the space shuttle who's 5.2 kilometers from the launch pad, and we want to find the height of the rocket if the angle of elevation is 37 degrees. The angle of elevation is really the angle at which the person, the observer, is looking up at the rocket. So we'll draw the observer over here, a little stick figure, and this is the launch pad. I'll put LP for the launch pad, and he's 5.2 kilometers from the launch pad. Find the height of the rocket. This is the rocket right here. I want to find out how high that is off the ground. Obviously the height will make a right angle with the ground. And I'll finish it off to make a right triangle. The angle of elevation is really the angle at which the person is looking up. That's 37 degrees, that goes there. So that's our angle of elevation. It's the angle at which the person is kind of tilting their head up to look at the rocket. So we want to find this height. Well, in relation to that 37-degree angle, this right here is the opposite leg. I'm going to label it as opposite. This is the adjacent leg. And for right now, we don't care about the hypotenuse. So since I want to know the opposite leg and I have the adjacent leg length, I need a ratio that relates opposite to adjacent, and that is going to be the tangent ratio. So I have to use the tangent ratio here. So the tangent of that angle measure, 37 degrees for part A, let's do part A over here. The tangent of 37 degrees is going to be opposite, which is the height of the rocket, over adjacent, which is the distance from the person to the launch pad, 5.2 kilometers. So I just need to solve that equation. To solve that equation, I'm going to undo division by 5.2 with multiplication, multiply this side by 5.2 also, and this will cancel, and I'll end up with the height of that rocket is equal to 5.2 times the tangent of 37 degrees. And we can go right to the calculator to find out what that is. 5.2 times the tangent of 37 degrees. No, I'm not using tangent inverse this time. We're not looking for an angle measure. We have the angle measure. That's 3.9 kilometers approximately. So the height of the rocket for part A is about 3.9 kilometers. Let's look at part B. For part B, how far is the observer from the rocket? Well, if the rocket's here and this is the observer, we want to find this distance. So basically we want to find the length of the hypotenuse on that right triangle. I was given the adjacent leg length. I want to know the hypotenuse, so I need to know what ratio relates adjacent to hypotenuse, and that's going to be the cosine ratio. So the cosine of 37 degrees is going to equal adjacent over hypotenuse. So 5.2 over x, I'll call it, for the hypotenuse length. The variable we need to solve for is in the denominator. You can multiply each side by x and then divide by 37, or you can use what I call the butterfly method. Just make two ratios equal to one another to make a proportion. And 5.2 times 1 will equal x times the cosine of 37 degrees. Now the cosine of 37 degrees, that's just some decimal. Let's see what that is. It's about 0.7986. So if you want to write down 5.2 equals x times 0.7986, you can. Or you can just divide each side by the cosine of 37 degrees. Remember, we're really just dividing by 0.7986 each side of the equation. So I'll go to the calculator, I'll move this up, and I'll do 5.2 divided by the cosine, 37 degrees. And I get about 6.5. So the distance for part B, this is part A's answer, part B's answer, the observer is about 6.5 kilometers away from the rocket when the angle of elevation is 30. It's about 6.5 kilometers when the angle of elevation is 37 degrees. For part C, what's the angle of elevation when the height of the rocket is 30 kilometers? So when the height is much higher up of the rocket, up here at 30. So again, the person's 5.2 kilometers from the launch pad. Here's the person. Here's the launch pad. Now the height of the rocket is 30 kilometers. Okay, let's move this over here. So we'll go ahead and finish off the right triangle. The height would make a right angle with the ground. So this time I want to know what the angle of elevation is this time. He's going to be looking up at a much higher angle. He's going to have his head tilted back much higher if he needs to see the rocket 30 kilometers up in the air. So this is in relation to this angle, this is the opposite leg, this is the adjacent leg, and opposite over adjacent is the tangent ratio. So the tangent of that angle would be opposite 30 over adjacent, 5.2. So I need to find that angle measure. So what I'll do is I'll just do the tangent inverse of 30 divided by 5.2, and that'll give me the angle measure that I'm looking for, the angle of elevation. Tangent inverse, 30 divided by 5.2. That gives me about 80.2 degrees. That would make my neck hurt looking up that high. So it's about an 80.2 degree angle of elevation for part C.